Hello, this is the front-end web development class. My name is Jeffrey. We're going to start on our recap. So last week we started talking about JavaScript. So for our recap, we'll start talking about JavaScript. Let's talk about JavaScript. So last week we talked about how JavaScript is the behavior triumvirate, the behavior part of the language triumvirate of the web, basically. A web page is made up of HTML, and most likely it has some CSS and JavaScript on it as well. So in the last class and in this class, we're going to be talking about JavaScript only. We're going to be talking about it all on its own as just a language. This last week was a good class for people who have never programmed at all, and this will be a continuation of that. So I'll talk about some of the different sorts of things we learned last week. What I'd like you guys to do is go to any page. You can even open up a new tab, right-click, and go to Inspect. And once you go Inspect, you can go to the Console tab up here and start typing some stuff. So yeah, let's type some stuff into the console. The console might show up. These dev tools might show up on the bottom or the right. I docked them to the right because I was working on some stuff. I'll put them on the bottom. It's not really a big difference. Cool, so let's see what we've got here. Actually, I'm going to keep it docked to the right. I like that. Good. Okay, so last week we did things like 1 plus 1, 2. We did 1 plus 3 times 5. Oops, times 5. 16. We learned that, basically what we've got here, this console, allows us to provide some input and get some output. And as you can see, we can just do some math, really some basic math or some complex math, whatever sort of math we want. But we also learned that this console allows us to store values and use them for later. So for example, if I want to store this for later, then whenever I type sum, I'll get the result of that. So we broke this down a little bit. What we said was that there are a few things going on in this line. The first thing that's going on in this line is a little mathematical operation, addition, between two numbers. Actually, sorry, before that, the very first thing that's going on here is that we're saying that on this line, we're going to be declaring a new variable. We know that because it starts with var. Any line that starts with var and then has something like sum or whatever else, that's us creating a new space in our memory called whatever we want to call it. I talked about memory last week. I talked about variables as basically you've got a big cubby with a lot of holes that you can start to create. And every hole can be labeled a certain way. And so for this one, we've got a new cubby hole called sum. And right now, we are assigning to this cubby hole the result of 1 plus 1. So 3 things going on here. Declaring a variable, doing some math, and then assigning the result of that math to that variable. So that means from here on, whenever we say sum, we get that value. Yeah.
Can I come from an electrical thing? Can I come with the idea that that's a formula for 2?
Nope, you can't. Basically, no. This is not a formula for 2. This is not saying because there's no formula. It's more the result. You've got the final value here. I mean, are you talking about this line being a formula? Because no, it's not. Because what's going on here is there's no formula going on. There's basically just saying that sum is not always going to be the result of these 2 things. Like, let me give you an example. Let's say that we've got 2 variables like var x equals 1, and then var y equals 2. Now we're going to say that sum is going to be x plus y. So right now that means sum is 3. Now here's a question. If I change x to something else, like I'd say that x is going to be 10, is sum going to change?
Yes.
Nope, it's not. Sum is not going to change because it's already been done. This math has already been done. It's all complete. Sum is not a formula of x plus y. Sum has been assigned the results of doing this operation at that specific point, and it stays that way. It's just a number. even though we use two variables, one and y, x and y, which store 1 and 2, to get this result, doesn't mean that sum has any further relation to x and y after this line is over.
Once you declare it, it's on its own.
Yeah, it's on its own. In today's class, though, we are going to talk about creating functions, where last week we ran some functions. We ran alert and confirm and prompt. We ran some things that look like this. You run it, and something happens, and you get a result. You run this, and you can type something into this field, and then you get that back, input and output. Those functions allow you to pass something in, have things change it around, and get some output. So that is more the sort of formula you're talking about there. But yeah, these variables, on the other hand, variables are never formulas. Variables are values. Some values can be functions, but we'll talk about that in a little bit.
I
Yeah.
guess I was trying to get you to sum is the label of the function.
Nope. Sum is not the label of any function. No, there are no functions on this line.
I mean, label of the variable. It's the variable.
Yes.
It's labeled on the variable.
Yes, that's right. Yeah. So, like I'm saying, picture a cubby. Right now we've got a cubby with a few holes in it. We've got a little cubby with a label on the bottom that says sum. We've got x. We've got y. Right? And each one of those, we've put values into them. In sum right now, there's 3. In x, there's 10. In y, there's 2. We can change these around, though. We can take that value out. We can basically say, instead of 10, let's say that x is now 20. So now x stores a little value called 20. And every time we refer to these things, it's kind of like we're taking that value and just doing whatever we want with it.
So basically what happened is 3 became x and y, and freed x and y up for later discovery. They freed up to be something else again. So
three didn't become anything. 3 stayed a number. What are you looking at specifically? Sorry?
X and y.
X, all right, so x.
Plus y gives you 3, right?
Well, yeah, let's say x and y right now give you 22. Now that we've got this value, 22, it's no longer x plus y, it's just 22. So we just took the value of x, took the value of y, took them out of their containers. Now we just have 2 and 22. We don't have to worry about variables anymore. We've just got 2 and 22. And then we just mash them together to get 2 and 20. We mash them together, we get 22, right?
What I'm saying is, I'm trying to understand how the x becomes available for 10 again. So we changed it.
X isn't available for 10. I put something new into x.
You changed it earlier.
Yeah, so I'm going to change it again back to 10. Now x is 10 and it's not 20. We just got rid of that previous value. That value 20, it's gone. X now has the value of 10. Cool? All right. So yeah, that's variables. X plus y. We can use variables to get equations together, but and we can even do it with like stuff like this. I mean, just keep on using it. You just think of all you do in your mind is when you're looking at this, you just replace each one of these things with the value. So like if x is 10 and y is 2, then this line could also be seen as, oops, sorry, not 3. Right? See? Same thing. Why is that? Because last I checked, x is 10. And last I checked, y is 2. So this is the same as that, right?
And that's a string?
Nope, that's not a string. It's a statement. It's a line of JavaScript. There's no strings involved here because you don't see any quotation marks. All this is a series of different operations of numbers, which you see here in blue. And this line of JavaScript can be executed. You can input it, and the output is 31. Yep. So let's talk about strings. So here's hello. Here's a string. This is a different data type. Instead of numbers, we've got characters. Now you can't do math on this stuff. These are simply just like a series of characters, one after another, that all come together. And the most, you can do a few things with strings, such as concatenating two of them. Concatenating, you use the plus operator for both concatenation and addition. When you have two strings, or at least even one string on the left or the right, you put them together into one thing. So it's basically just taking all of these different characters and all these different characters and putting them together, and here's the result. So you got hello world in response, right? And just like being able to assign numbers to variables, you can assign strings to variables. So if I want to say x is hello, then great, x is hello from now on. What's x plus y? Well, what's y first? Y is 2, right? X plus y, hello 2. Now this is weirdness. This is strange behavior, and it's kind of specific to JavaScript. What JavaScript is trying to do here is it gets the value of x, which is hello. It gets the value of y, which is 2. And then we've got this plus operator in the middle. And it doesn't know how to do addition of a string to a number, but it does know how to do concatenation of one string to a number. What it does is it transforms this number into a string. It's called casting. Casts this value 2 from number into string, and then it's able to put them together into a single string. So this plus operator, little plus sign, does different stuff depending on what type of data we have on either sides of that operator. Yeah.
And I was wondering, I'm remembering the equal operator. I was wondering why, because it changed in real today. I think it changed. We changed assignment abilities today.
Today? Did something happen today?
In the like what I was thinking of a string.
Yeah.
Isn't that different than what you call concatenating when you put in quotation mark? Doesn't that denote something different action?
Well, yeah. This operator doesn't combine two values together. It basically takes the value on the right and assigns it to the variable on the left. You'll only see this equal sign at play when you've got a variable name on the left of it. So this equal sign is only used to take a value on the right and assign it to a variable name on the left.
I think that's no question.
Yeah.
There's no cases where you have a double plus sign like you have double equal sign in JavaScript.
Okay, so I haven't even gotten to double and triple equal signs. You can do triple equal signs. Sometimes you can do double equal signs, but they're different. Those are different operators. Even though they've got the same character in them, 3 of them in a row is entirely different than 1 in a row. But you asked about double plus signs. Yes, you actually can do that. Let's say that we've got x, or let's say y. Y is 2. If you say y plus plus, then y will now become 3. Let's do y plus plus again, and y is now 4. Don't worry about this output here. It seems to have given me the output of the previous value of y, but every time I do a plus plus, it adds 1 to it. So yes, there are operators. There are these double plus operators, and there's also double minus operators. Now y is 3. Now y is 2.
Wow.
Now y is 1. Yep. There's also y plus equals 1, which adds 1 onto it, or y plus equals 10, which adds 10 onto it. So this plus equals operator is assignment, but instead of simply setting this value to that, it sets it to the value of whatever y is plus this.
Is that modulus?
Modulus? No. The modulus operator looks like this. And that gives you the remainder of a division. So basically, if you were to divide 4 by 5, you get a remainder of 4. Is that right? Yeah, whatever. Divisors and quotients and stuff like that, I'm not really good with that. But this is the mod operator, and I don't really have to talk about it because it's not usually important. We will use it in a future assignment, but it's not going to be very complicated. Yeah, so there's some different stuff you can do. There's also minus equals. So if I wanted to say y minus equals 10, then all of a sudden that is subtracting 10 from the current value of y and reassigning it to that new value. Cool? So that's a little shortcut right there. You could also, so this is the same thing as saying y equals y minus 10, right? These two lines, y is being assigned the value of y minus 10, or you can say y minus equals 10. These two things are the same. Cool. So there we go, a little bit more math. So back to strings, as you can see, you can add some stuff together. You can add you can add as many strings as you want. And they don't have to be words. You can say
but they have to be the same category of characters, right?
Well, they have to be strings. I don't know what you mean by saying category.
Oh, that's right. You can use alphabet and numbers.
You can use alphabet. You can use spaces. You can use punctuation. And you can also use numbers.
Is there anything you can't use?
Inside a string, you can use any character. You can use emojis in your strings. Cool. So there you go. Good. See? So that's concatenation of two strings. This is a character. It's part of Unicode. And then this is just a string with a space. Is space great period. Altogether, that's what you can do with strings.
Would it help us to learn familiarize them with ASCII or Unicode?
What?
Would it help us to know that Unicode and ASCII?
What do they have about Unicode or ASCII?
To know it. To know that.
Do you have to know it?
Would it help to know it? Would it help know it?
You mean knowing like the character codes and everything?
Yeah.
No, you don't need to know that. No, it's not important. Okay, so other stuff that we learned about last week is we learned about equality. So for example, if I said hello is equal to hello, I would get a special value called false. So why are these two things not equal to each other? This has an uppercase H, that has a lowercase h. So this 3 equal sign operator here takes these two values and compares them. And based on whether they're the same or not, it gives you a new value called true or false. So it's an operation, just like plus or minus or subtract or concatenate or whatever. But what this one does is takes these two values and turns them into a Boolean. A Boolean is a value which can be either true or false. So this is true, right? We use 3 equal signs because 2 equal signs means something slightly different in JavaScript. It's called weak comparison, where you have weird stuff like this happening, where this number is equal to this string, and that's true. And we don't like doing that, so we always use triple equals because we want to be able to compare numbers to numbers and strings to strings. And if there's ever a case in which we're comparing a number to a string or a number to something else, we should not be told that that's the same value because they're not. It's the responsibility of JavaScript programmers to know which types of data they're working with. If you're passed in a string and you expected it to be a number, you should have to handle that. You should check to see if it's one or the other and do something about it. Yeah.
Back to the hello and little hello.
Yes.
Isn't the case sensitive rule more important than that false or false more important?
It doesn't have anything to do with, well, so there's no such thing as case in strings. Uppercase H is a different character than lowercase h. That's all there is. So these two characters have nothing to do with each other other than the fact that in the English language, uppercase H and lowercase h are uppercase and lowercase versions of one another. In JavaScript, there's no such thing. It doesn't, yeah. So Yeah, I mean, like, it's just that uppercase H is a different character than lowercase h. And so these 5 characters are different than these 5 characters. Or at least the first one is, of each, right? So it's not about case insensitivity or whatever. It is certainly case sensitive. So
once you put it in that the quotation mark, you know, it's a string, and that isolates it, and it has that rule of being a string.
I guess, I mean, you know, if you have them outside of the strings, then you're going to have other problems. This is going to say hello is not defined, because when you have things outside of strings, they're expected to be variables. So, you know, I haven't done var hello, and so I can't say hello or whatever else. It's not defined, so I get an error when I try to do that. So I'm not exactly sure what your question is, but basically, if you want to have characters and you want to do comparisons or concatenations or whatever you do with strings, you have to put them inside quotation marks. Ah, yes, that's true too. So, for example, if I had var hello equals 3, and I tried to say hello, I would still get undefined, right? Like I said, JavaScript is case sensitive, both with strings and also with variable names. So here with this uppercase h and lowercase h, these two things are different. I can say var hello is 4, and I say hello, it's going to be 3. I say lowercase hello, it's going to be 4. Are these two things equal? Nope, they're not. But they're both defined, so we can do that comparison, right? So yeah. Here's another one. Hello is now equal to 3. Is this going to be true or false? False? You think it's really false? Mm-hmm. So what's the value of uppercase h hello? 3, right? What's the value of lowercase h hello? It's 3, right? So it's true, right? That's because they're both pointing to the same value. Remember, whenever you see variables, in your mind's eye, what you should do is replace this with whatever its value is. That's the first thing you do. So whenever you see the word hello, and you know what the value is, that 3 up there, you just pretend that this has turned into the number 3. Do the same thing here, then you do the comparison, right? So that's how it works.
So that's the true, for a program, that's a true representation of the math form of E.
I don't know what that means.
I mean, that's what equal. That's going to equalize. But you have to do that.
This isn't changing these two values. This is just comparing these two values. This is a comparison operator. It's called the strict comparison operator. It's checking to see if the value of this variable, or whatever this thing is on the left, and the value of this are the same. That's all. And then it turns it into a Boolean, true or false. So when I say turns it into a Boolean, so look at this line. Var are those equals hello is equal to hello. So this is a weird looking line, and it's worth taking a look at. We've got a single equals sign. We got a triple equals sign. So what happens first? Anyone want to walk me through the stuff that happens in this line?
The comparison happens.
Right. Well, even before that, even before the comparison happens.
Are those equal?
Assign the variable.
That's right. Well, we don't assign the variable. That's one of the last things that happens.
Declare it.
We declare the variable. That's right. First thing that happens is we declare the variable. Are those equal? Great. What's the next thing that happens?
Then you do the operation.
Takes the value of hello.
Huh?
Takes the value of.
Yeah, it takes the value of each of these things.
Right.
It basically looks up. Oh, look, these two are variables. I'm going to get the values here. So now you basically got these two pretty much in the background equaling whatever they're. Then you do the comparison, right? Then once you do that, then you do the assignment. So all that said, what will the value of are those equal be?
True.
Correct. It will be true, right? Because hello is equal to hello is true. You take that thing here, you do the operation, you get true back, and then you assign it to are those equal. So when I say are those equal, I get true, right? Another thing I talked about last week was camel case, uppercase T and uppercase E. That's just what I use when I'm having variables that I think deserve more than one word to describe what's going on there. I like creating variables that make sense, that have sensical names. Make them as long as you want, just as long as they make sense to you. But you can't have spaces in them. You have to have something like that. All right. We also talked about if statements last week, where we used these Boolean values to either run code or not run code. So if you want to download the stuff from last week, you can do it, or just work on your own stuff from last week. Let's take a look at what I did last week. I'm going to open up this index.html, and we've got a very, 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 very simple HTML file that has a single script tag in it that loads up our JavaScript file. This is the easiest, most straightforward way to load up a JavaScript file in your browser. So this is what our app looks like. That's a lot of JavaScript code. A JS file can contain multiple lines of JavaScript. They'll just run one after another immediately. Immediately when the file loads up in the browser, it will run everything. But of course, certain lines will only run based on what's what. This line right here, should show alerts equals confirm, do you want this to work? The first thing that happens is this confirm function gets executed. Confirm is a function that's built into the browser. So when we pass this string into confirm, it's going to pop up that little dialog box. And confirm is going to have a dialog box with two buttons, cancel or OK. If you say cancel, then should show alert gets assigned false. If you say OK, then should show alerts gets assigned the value of true. Based on whether it's true or false, lines 4 through 6 will run. That's what this if statement is doing. This if statement expects to have a Boolean value passed into it. So whatever this thing resolves to, if it's true or if it's false, or if it's a truthy value or a falsy value, in some cases you can even use something like the number 1 or the number 0 to mean false, or certain strings to mean yes or no or whatever. But I would recommend that you stick with Booleans. Whatever you pass into this thing will determine whether this code runs or not. And this alert thing is, of course, just running three alert functions one after another. On this line, I just demonstrated that you can use different combinations of quotation marks to get what you want. If you use a single quote, then you need to backslash any other quotes inside them in order for the string to continue. This is called escaping. When you escape a character, you're making sure that the character isn't interpreted as part of the language. Rather, it's interpreted as part of the string. So this little backslash here makes sure that this little quotation mark isn't going to prematurely close our string. This is fine. We don't need to escape this one because they're double quotes. But we do need to escape these two double quotes because we started the string with a double quote. So, oops. As long as you've got double quotes on either side, then you can use as many apostrophes as you want. Once you use double quotes inside there, you need to escape them. All right. Next up, this is just me talking about how I'm assigning a new value to should show alerts. So even though this code ran with if should show alerts, this code will never ever run because the line right behind it has reassigned the value false to this variable should show alerts, right? So line 12 will never run. Next up, I'm asking for someone's favorite color. I prompt, what's your favorite color? And based on what they type in, well, whatever they type in will be assigned to favorite color. So in this line, I'm creating a new variable, favorite color. I'm calling a function, prompt, asking what's their favorite color. And the result of this gets assigned to that variable, favorite color. So if favorite color has been typed in as lowercase blue, then I will alert, wow, how unique. Now these else statements allow us to have a little second chance. What if this is false? Well, maybe this will be true, right? So if this is false, then we go ahead and check to see if this is true. If favorite color has been typed in exactly like that, then we go ahead and alert how exotic. Otherwise, we just do that. So if this is false, and if this is false, oops, this is false, then we do that. So in every case, we're going to be alerting something, but depending on whether these triple equals comparisons are true or false, then we will alert one of these things out. So the way that this code runs looks like this. If you want this to work, remember, if I say OK, then I'm going to get 3 new alerts. So I'm going to do it. I'm glad this worked. This will work too. I'm glad this worked. See those quotation marks in there? Right. What's your favorite color, right? So that's me on line 15. You'll notice that it skipped right past this stuff because this will never run because should show alerts is false. What's your favorite color? Let's say periwinkle, right? So it's not going to run this because favorite color is not triple equal to blue, but it is triple equal to periwinkle, so it's going to say how exotic. And that's the end. That's the end of the code. It's done running. I should note that even though it's done running, it has declared some variables like favorite color and should show alerts. So as long as this page is open, I have access to those things. So based on what's been set in the code, these variables are still accessible to me inside this little console where I have access to the global scope of the page where all these variables have been assigned into. Global scope is something I haven't even talked about yet. I'll talk about that near the end of this class. So I think that we're about ready to get started on new stuff. Let me see if anyone has any questions online. I forgot to turn on Q&A. Oh, there we go. Hi, Henner. Hey, good question. Transfer 8-bit binary data into strings or arrays. Good question. Well, what I will say, interestingly enough, is that parseInt allows you to take octals and try to, oh, never mind, turn them into things. But maybe that's not exactly what you want. But yeah, binary data is more like, I don't know. And so that can parse a binary string into stuff like that. But it always translates it into numbers. So I'm not really 100% sure about doing that into strings. I'm sure that there's a lot of bitwise operators that are available in JavaScript. But beyond that, that's really kind of not within the scope of what I know or what I do on a daily basis. So yep, sorry I can't exactly answer that question. You're kind of way beyond me on that. Okay, so let's start some new stuff. Hi, this is the front-end web development. Hi, this is the front-end web development class. My name is Jeffrey. Let's talk about more JavaScript. Cool. Okay, so I just finished talking about the recap, talking about these if statements. Now, there's another if statement that I want to show you guys. By the way, if you want to continue along, if you want to download this code, you can. If you don't have it in front of you already, then you can go to the wiki page. You can scroll down to the bottom here and look at, you can get the class materials. You can either clone it. If you went to my Git class and learned how to use Git, then you can clone my repository, or you can do a Git pull if you already have my repository to update to the latest stuff. If you don't know how to do that, then you simply just click on this link to go to the FWD repository, github.com/jeffreyhw/FWD. You go ahead and clone or download. It's this button right over here. And you can just download the zip file if you don't want to deal with all that stuff. If you do download the zip file, then you can find the stuff that I worked on last week in Series 10, Class 4. I'm going to go ahead right now and make a copy of Class 4 called Class 5, and just, oops, not Class 45. There's not that many classes. And I'm going to just continue along with my work. So you can do the same if you feel like it. I would recommend, though, that if you are working within the checkout of my repository, that you don't change anything around, because that's going to cause some problems the next time you do a git pull. You're going to get some merge conflicts. So if you do want to work on your own stuff or just write your own code, I'd recommend not doing it in the cloned repository of FWD. But if you download a zip file, then you can do whatever you want inside it. There's no connection to my repository or whatever else. Okay, so Class 5. Let me go ahead and delete a few things that are unnecessary. So again, index.html has nothing in it besides a script tag, and app.js has a few lines of stuff, most of which we're going to comment out because we don't really want to have it run over and over. Okay. By the way, if you are making changes, or if you were looking at my app.js from the previous week, make sure that the version that you're editing lives inside your class 5 folder, not inside class 4. If you want to find out in Sublime Text, you command-click on the title bar and see the hierarchy there. Or you just close it and open it again and make sure that you're working on the class 5 version. Okay, so again, we got some variables. We ran some functions to assign those variables. We're running some other functions depending on whether this code is true or not, etc., etc. Now, I want to change this line from if to while. While is like an if statement, but this code runs forever. It just runs over and over and over and over and over forever. So let's see that work. I'm going to open up, this is class 5. Do you want this to work? Sure, let's press OK. I'm glad this worked. This will work too. I'm glad this worked. I'm glad this worked. This will work too. I'm glad this worked. This just goes forever and ever and ever and ever. Great. So we probably want to prevent this page from creating additional dialogues. Okay. But now you'll notice that probably my CPU is being used up. It's 100% CPU usage. If I take a look at my task manager down here, you'll see that this tab is taking up a whole lot of CPU right now. A lot. The reason for it is because this stuff in the background is being run over and over and over indefinitely. It's probably run millions, if not billions of times already, just in the background with me sitting and talking to you about this. So I want to go back to Chrome and close that tab. It's not even going to let me close it unless I press that thing there because it's in the middle of doing a lot of important work, right? So that's what happens. That is called an infinite loop. Whenever your laptop's fans turn on and you see that you've got something in your task manager or something that's taking up all your stuff and you have to go ahead and kill it, it could be an infinite loop. It could be that someone did some bad programming and accidentally got into a situation where the same code just runs forever. So you don't want that to happen. So how do you get out of this while loop? Well, you can go like this. Right? So see what's happening. I said should show alerts. If it's true, it's going to run this code, run this code, run this code. Then it's going to run this code, which is should show alerts is now false. Then it checks this again. It checks should show alerts. Has it been changed? Is it now false? Yes. So that means this is only going to run once. So it's pretty much like an if statement now. You know? So like, in other words, this is pretty much like this. Right? Oops, sorry, if. Let's try that again. Because it only runs once and then it turns itself off. Cool? But that's what a while loop does. Now, why are while loops important at all when we could just use if statements? Why is it important to repeat something over and over indefinitely until the end of time? Well, it's probably not. But what you can do with while loops is do something a certain amount of times. Let's say, for example, that we've got a number like, I don't know, 5. Okay? Actually, let's put it down to 3. Number of times is 3. So instead of should show alerts, I'm going to say while number of times. Actually, I'm sorry. I'm going to start with number of times is 0. But I'm going to say while number of times is less than 3. Here's a little operator which means less than. You've probably seen this in math before, you know, one way or another, arithmetic, algebra, whatever. It means the same thing here than it does in math. It basically says whatever's on the left is less than 3. Remember, this little thing is an alligator, which likes to eat the greater value, right? And that's on the right. So this is less than 3. So, but what's unlike math is that this operator here operates very much like that triple equal operator in that it turns both of these values into a Boolean. It either becomes true or false, right? So take whatever's on the right, take whatever's on the left, compare them to see what's, whether right is greater than left. If true, it becomes true. Cool? So this code is going to run every time this runs. So instead of saying should show alerts false, I'm going to say number of times is equal to itself plus 1. I showed this little operator in the recap, but I probably didn't show it last week. So this little operator here, plus equals, takes this value, adds 1 to it, and then reassigns it to that thing. So it's called an incrementing operator. It basically just takes whatever this value is and adds it onto that, and now that's what the new value is. So every time I run this, it's going to number of times. If it's 0, it'll become 1. If it's 1, it'll become 2, and so on. So as you can see here, this runs first. Then it checks to see if this is true. If it is, then it runs these 3 things, and then at the very end, it adds 1 to this. Then it does this again, and again, and again, until this becomes false, and then we can move on with our lives. Cool? So let's try it out. How many times total do you think we're going to get alerts within this while loop? You think you're just going to get 3 total? So 1, 2, 3. That's it.
Oh.
9 times. That's right, 9 times. Because these 3 will run, and then number of times will now be 1. These 3 will run, number of times will be 2. These 3 will run, number of times will be 3. So it's only 3 times. And 3 must be less than that. So it's 0, then 1, then 2, and then once 3 is less than 3, that's false, right? And so it's not going to run it ever again. So we'll get it 9 times. Let's count. I'm going to also comment out this line up here because we don't really care about it. Yeah. This is a single line comment in JavaScript. This basically means that I can just take one line and just hide it. It doesn't do anything. It's just going to be completely skipped over. All right, so let's run that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's another dialogue later down on the page, right? So what that did was it looped. This code make sense?
I went fast. I was really not time how
Okay, so a while loop runs this code forever if this is true, right? But every time it runs it, if the value changes, then it has to make this comparison again, right? So number of times is 0. After we run this line, what is number of times? 1, correct. Is 1 less than 3?
Yes.
Yes, so it runs this again. Now we add 1 to it. What is it? Wrong. 1 plus 1 is 2. We go ahead, number of times, is 2 less than 3? Yes, so we run this code again. Then we say plus 1. What does that become? 3. Is 3 less than 3? No, so it doesn't run it ever again, right? That's how it works.
That's not stop.
That's why it stops. That's why we're not in an infinite loop, because after a certain point, this thing becomes false, and then we just continue on.
And it's got to,
You'll get it.
I see, I kind of see.
You'll get it. Well, we're going to keep working on this. So this while loop is nice, but it's a little rudimentary. It's a little wordy. There's this part where we have to start something. There's a part where we have to check over and over whether it's something, and then within the while loop, we have to say number of times is greater than 1. That sort of pattern, you're going to see it very often in JavaScript. So often, in fact, where you have to start with a value, check to see what that value is, and then add to that value. We see that little loop so often that we have another construct in the language called a for loop, which kind of makes this a little bit easier to look at. Well, not easier to look at, but a little easier or more compact, straightforward. Using words easier, straightforward, and they're not necessarily true, but it makes it more compact to write. So it looks like this. So, take a look at this, and take a look at this. You might notice a lot of similarities. First of all, number of times equals 0. Look, that's right here. Number of times less than 3. Look, that's right there. Number of times plus equals 1. Look, that's right over there. And you'll notice there's a little semicolon separating those three things. So this for loop does the same thing as this while loop. Yep.
So to summarize it, the first part is the declaration.
It's just the initiator, essentially. It's what happens at the very beginning of the for loop. Before it even begins to loop, what happens?
Okay.
This thing happens once. It's sort of it's just setting things up.
So initiator, and then the second one's parameters, and then the third one is.
So I mean, if we're going to use words, fancy words, whatever, I'd say this is the initializer. This is the conditional, essentially, and then this is the incrementation step. So, but a better way of putting this is what happens at the beginning. This is what happens before every loop to see if it should continue, and this is what happens at the end of every loop. Right? So, it starts out saying number of times is 0. Then it says, is number of times less than 3? Yeah, so it's going to run this. Then, before it can check again, it runs this final line. Number of times plus equals 1. Then it checks this again. Is number of times less than 3? Yes. Number of times less than 1. Number of times less than 3? Yes. Blah, blah, blah. Number of times less than 1? No. Done with the for loop. See? So it's just the same as this while loop, but those three things, number of times, number of times, number of times, they're all right here, one after another. Yes?
Is that the structure of a for loop, or does it get loops?
That is the structure of a for loop. I mean, it doesn't have to. You don't have to use the word number of times. In fact, a lot of people like using the variable I, which is very short. I stands for iteration, oftentimes. So people often use I when they're iterating through a for loop. This is the same code. It just looks a lot smaller and a little harder to read, right? But it's the same stuff. I just use I instead of number of times. So this is what for loops look like, at least in JavaScript, and also in a lot of other languages too. So there you go. And that's why that code works. So now that I've got that for loop, I'm going to comment out this while loop code, because that'll get really annoying if I do it over and over. Commenting out multiple lines of code, you use different delimiters in JavaScript. You start out with /*, and you end with */. So these little delimiters, you can put them anywhere, but anything in between those things gets completely skipped over. As you can see, it all turns gray in the text editor, right? So there are two kinds of comments in JavaScript, single line or multi-line. Cool. Yes? It's a really good question. I don't use while loops very often.
I find for loops are more helpful, but then I know that while loops exist.
Yeah.
I can only think of like if you're playing a game and then it's like while the person says
Yeah.
it's okay to play.
I'll say that a while loop is better to use when it's not necessarily the case that there's going to be an ending step that always happens. Like, for example, there could be a while loop where it's like, it's just going to keep going and going and going until something happens, but not necessarily like a number is reached. It could be that it just keeps going through and randomizes a whole bunch of names until the name is not Tom, and then all of a sudden the while loop stops, right? So due to randomization or due to other sorts of iteration or deep nesting structures or whatever, there's a whole bunch of different reasons why a while loop might be more useful than a for loop when you want to iterate through code. There's also the concept of recursion, where you create a function that calls itself, but we haven't even talked about creating functions yet. So, either way, there's a lot of different ways to loop through stuff in JavaScript, and there are a lot of built-in functions that allow us to iterate through different sorts of structures, which we also haven't started talking about yet. That said, I think that it's time for us to start talking about said structure. So that's a good segue into our next thing. Let me just double check if anyone has any other questions online. Rather than doing tons of else-if statements, can we have the program check a bunch of colors at once? So you're seeing if the color is within a certain list of possible colors. Yes, we can do that. And I can talk about that very shortly. Actually, that ties into what we're going to talk about very soon. So yes, if I don't talk about this, then try to remind me in like half an hour that I haven't exactly answered your question. But the answer is arrays. So let's talk about arrays right now. Cool. So I'm also going to comment all this out. Don't need it. Let's take a look at arrays. So far, we've learned about 4 different data types. We've learned about numbers. We've learned about strings. We've learned about booleans, true and false. We've also learned about functions, which are a data type all their own. Even though they're just like words like alert and confirm and prompt, those names are really just variables whose cubbyholes are currently storing a function. So we'll talk about functions a little bit more in depth and the ability to create our own functions. But before I do that, I want to talk about a 5th data type called an array. Take a look at this. So, in case you're keeping track, in case you've ever taken any college courses, we've already just blazed through Comp Sci 101 in the previous class. And this is Comp Sci 102, data structures. So we're talking about data structure here. This data structure is a list of numbers. This list is called an array. Arrays in JavaScript are denoted using square brackets. Square brackets on the left and the right. So what's going on here is that this array contains not 1, but 10 values. And they're in order. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That is the order that they're in. It starts from 1, goes all the way to 0. It's kind of funny, 1 to 0, whatever. Anyway, that's all well and good. But now that we've got 10 of these things, what can we do with it? Can we concatenate? Can we add? Can we do other sorts of things that other data types can do? Kind of. But let's work first on trying to get certain values out of this thing. Let's say, okay, don't freak out. This looks a little weird. R bracket, 0 bracket starts to look like actual real programming. What this is saying is let's get the 0th value out of this array. So this is a trick question, but what is the 0th value of this array? Huh? Yes, so what's the value? It's 1. So why is it 1? Because I said 0, so why isn't it 0, right? Because 0 is in this array. Well, this number is different than these numbers here. These numbers are values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Those are values inside this array. But when I take an array by its name, and then I put little brackets right after it and pass a number into it, what I'm doing is I'm going to start counting. And numbers like to count from, computers like to count from 0, not 1. So they go 0, 1, 2, 3, 4. I'm going to start at 0, And that's index 0 of this array, which is going to be 1. Array index 0 is 1.
Isn't there another way of saying that 0 is a group by itself and by virtually cancels out comparison?
Sorry, say that again?
Okay, what I'm getting is 0 is the equivalent to that whole array. Those are two, they're equivalent. They're both groups or arrays, right?
Nope. None of what you're saying is true. No. So let's continue. Let's do another array. Okay. So here's an array of strings. Hello world, my name, etc. Okay. So is this a different type of data than this?
No.
No, they're both arrays. But this array only contains strings inside it. Cool thing about arrays is you can put any data type within your array. So if I do array of strings index 0, what's that going to be?
Hello.
It's going to be hello, exactly. Because this is index 0 of this array.
Is that because they're first position or?
That's the first position, yes.
0 only has one position, so it's the first position by that virtue?
I don't know what that means. 0 only has one position. No, 0, the first item inside an array is at index 0. That's your answer. So index 0 of this array is 1. Index 0 of this array is hello. Now, let's take a look at another array. So this array contains some interesting stuff. Let's take a look at what's inside it. First thing is a number. So index 0 is a number. Index 1 is a string. Index 2, a Boolean. Index 3, it's a variable which is a function. That's right. What about this? Index 4. An array. I just put an array inside another array. Hey, yo dog, I heard you like arrays. Finally, undefined, which is that nothingness value.
It's a sum?
Huh?
It's a sum?
No, it's not a sum. Undefined is just nothing. You've seen this before, where in the console I start doing something like I create a new variable and I get back undefined. That's just nothingness. So what I'm doing right now is I'm dealing with nothingness. I'm harnessing it and putting it into my array at this thing.
Can't call it a result?
What?
Can't call it undefined result?
Undefined result? No. Undefined is a special keyword in JavaScript. Undefined result is a variable that I haven't declared, so it's going to give me I think a reference error because I haven't created a variable called undefined result. No such thing. But undefined is special because it refers to the concept of nothingness. It is a declared variable that remains having nothing inside it, I guess. You know. So yeah, there's that. Array of stuff is this sort of stuff. There's a cool thing that I can do in JavaScript where I can find out a certain data type of certain things. So I'm going to go ahead and run this code again and check out array of stuff inside my console. Just going to go through this stuff. Great. So let's check out array of stuff. Array of strings, array of stuff. So it looks a little bit different in the console, but as you can see very, very clearly, these are all different things. 1, it's a number, string, Boolean, function, array, and then undefined. So array of stuff, index 0. Cool, it's 1, right? So let's check this out. Type of. So type of is a special keyword in JavaScript. It's like if, it's like for, it's like while, it's like var. It's type of. Type of gives us a string as output based on whatever we passed into it. So like, you know, type of 1, number. Type of array of stuff index 0, number. Type of array of stuff index 1, string, right? Type of array of stuff Boolean. Array of stuff 3, function. Array of stuff 4, this is going to be weird, object, not array, but object. And finally, array of stuff index 5, undefined. So all these things have different types, different data types. So this type of keyword gives us back a string representing what type of data we're dealing with at each position. And it doesn't only, like I said, it doesn't have to work with arrays. We can say type of, you know, hello plus 3. What's this going to be? It's going to be a string, right? Because hello plus 3 equals hello 3, and the type of that is string. Whoa! That's not what I expected. Oh, that's funny. It worked on this, and then it worked on that. So I guess type of works before 3 does. That's very funny. But if I did this instead, then hopefully it would work. Yeah, okay. So I learned something new today. That's funny. Anyway, so that little type of, this is not a function, as you can see. There are no you know, parentheses around it or something. It's just a special little keyword that allows us to take that, put a value after it, and then get a string back as the type of that thing. Something built into JavaScript.
What is the word for those keywords again? Like number, string?
Oh, they're all data types.
Data types.
Yep. So each one of these has a different data type. Cool. But as you can, yes. Sorry.
Can you explain why array of stuff in index 4 is not an array but rather an object?
Oh yeah. Why this is an object and not an array?
Yeah.
Because I haven't even talked about the actual object yet, but there is something in JavaScript called an object that can contain a whole bunch of values. And an array is a specific kind of object that has an order to it. The cool thing about arrays is that you can put a whole bunch of things into it, and each one of them is in a deliberate order. So each one of these has a different numeric index, index 0, 1, 2, 3, etc. But when it all comes down to it, it is an object. So we'll talk a little bit more about objects very soon. But we'll see why it tells us that instead of just array. Why there is no specific data type called array. We'll see. Okay, so that's cool. We have these arrays, right? And that's all well and good. So what else can we do with these things? Well, we can use them with for loops. We can use them also with while loops. You can use them with any kind of loop. But one thing that you're going to be wanting to do very often with an array is iterate through it, or loop through it. Iteration is just a fancy word for looping. You're going to loop through something, and you want to do something with every value in that array. One practical idea of this is, let's say that you've loaded up from some sort of database a list of different names, and you want to list all those names out on a web page. What you probably want to do with that list is going to come to you as an array. And you want to iterate through that array, and for every single name you want to print it out on the page. That's something that you're going to do constantly with arrays. So what I want to do here is log out every single one of these things. Sorry, not log out like computer log out, but log into my console every single one of these values. So we've taken a look at alert. Alert is kind of old and busted. Alert pops up a little dialog box. That's all well and good. But I want to introduce a better tool, a tool that you want to use when you go forward with debugging, and it's called console.log. Console.log is a method or a function that you can call, and it just prints something out straight into the console. It's really great. It even does it from a JavaScript file. So if you run this JavaScript file, you see any console log stuff, and they'll pop up right in the console automatically. So let's try it out. That's great, right? It's going to log out 1 into our console, right? Let's see that happen real quick. 1 second, just doing a little bit of housekeeping. Okay. So check it out. I'm going to reload. I'm glad this worked. Geez, rent this page. Check it out. 1. I just got 1 in my console without having to do anything. Where did 1 come from? Oh, it came from line 48 of app.js. See how it says app.js:48? It's saying right here on line 48, we had a console log thing. So it's easy for us to tell exactly which file at which point specifically caused that thing to happen, caused it to show up. Cool, so that's helpful, kind of. But wouldn't it be great if we could get all of that from the array? Well, the first thing we need to know is how long is our array? How many things are inside our array? How do we figure that out? Well, arrays have a special property living on them called length. The way that you access them is by doing name of array here, dot length. So it looks like this. If I was to go to the console here, array of stuff dot length, it's going to give me the number 6. This is not a function. This is not something special that I created. This is something that automatically gets set on every array. However many values are in that array, you just do dot length at the end of it, and that gives you the number 6. This little syntax where you've got a dot and then something that's not like a decimal point and not like a number following it, that it's some sort of word, is known as accessing a property. So this is a property accessor here. We're saying dot length on our array of stuff and getting the number 6. Cool? So that's built into every array. It just comes with it. So now that we have the length of the array of stuff, we now know how many times we have to loop through this console log in order to get everything printed out, right? We know we want to print out everything. We could just copy and paste this however many times. But what if we don't know what's inside the array of stuff? What if we don't know how long it is? So it looks like this. For var I equals 0. Start off at 0. Next, we're going to say, as long as I is less than the array of stuff length. Here we're saying start with 0 and keep doing the following code as long as I is less than the array of stuff dot length, which of course, as we know, is 6, right? Then increment I every time we run this code. Are we done? What do you think is going to happen? Could someone describe to me what they think is going to happen with this code? Let's just run through it. Again, start with 0. Keep running the following code as long as I is less than length, and then add 1 to I every single time. This line here, we're saying console.log array of stuff index 0. So what's going to show up in our console?
Hello.
Sorry, okay, I'm going to have people raising their hands because there's a lot of stuff and only one right answer. Yes?
It's going to list hello to alert R.
No. Yep.
It's always going to print. It's always going to print 1 because it's stating 0.
How many times is it going to print it?
However long the length is.
6 times. Yeah. So it's only going to print out 1, but it's going to do it 6 times. Why is that? Because we got the number 0 hard-coded right here. So this code is this line is going to run 6 times, but it's only going to run 0. So how do we get it to iterate through this array when we don't want this to be hard-coded as 0? What can we use instead? Why not I? We're using I up here. I is 0, I is less than array of stuff, I plus equals 1. But that doesn't mean that it has to stick within this little parentheses here. I can also be used inside the for loop. So I starts as 0, so we start with 1. Then I gets added, and so the next time we run this code, I will be 1, right? And so it's going to print out hello. Then it's going to print out true, then it's going to print out alert, then R, then undefined, right? Does that make sense, how we're using I in all these different ways? So let's check it out. There we go, check it out. It immediately happened. 1, hello, true, alert, array, undefined. See, it printed them all out. Yep.
Can I say I is a placeholder, like X in algebra?
It's a variable. That's what they are. Yeah. I, X, etc. Every single thing we've done so far is a placeholder for some data.
But I am trying to like kind of like obtain that as like lock that in as a reference point.
Yes, you can. You can, but not specifically. Every single variable we've looked at so far fits that description, what you just said. So R up here, array of strings, array of stuff, number of times should show alerts. Every single one of those is a reference to some data, in addition to I. So yes. Cool. So, any questions? Any confusion? Any questions online? Questions online? No questions online. Cool, all right. Neat. So we've learned how to iterate through arrays. We can also do some other stuff, like, for example, let's look at this. If type of array of stuff I is a string console.log array of stuff I.
Does it have to be in single quotes?
Huh?
Why does string have to be in the single quotes?
It doesn't have to be in single quotes. It's just my style, which is I like to use single quotes.
Okay.
Most people in the JavaScript community have finally convened upon, or upon using single quotes in most cases. I don't know. It really doesn't matter though. It doesn't make any difference in JavaScript. In other languages, it does make some difference, but not in JavaScript.
Okay.
Okay, so a lot of colors going on here, a lot of different sorts of stuff going on. This is quite dense code, but pretty much everything we've learned so far is within these 5 lines of stuff. We learned about creating variables, we learned about assigning variables, we learned about numbers, we learned about strings, we learned about comparison, we learned about looking up indexes of arrays, we learned about finding the length property of an array, we learned about incrementing 1 on top of I. We learned about if statements, checking to see whether this is true or not. We learned about the console and how we can log out a value. So quite a lot going on here. But you put it all together, and we say that we're going to iterate through this array of stuff. And whenever we find a string, we're going to print out that string. See? So if type of array of stuff index I, that is whatever thing we're iterating through, var I, etc., if that turns out to be a string, we're going to print it out. So how many times are we going to print it out? Once. Because how many strings are in this array of stuff? 1. So let's try this code. 1. Just hello. So I'm going to go and change array of stuff to array of strings. So now this code is going to iterate through a different array of strings. Save, reload. There you go. See? It printed everything out because all of these are strings. Hello, world, my name, etc. right? And of course, if I put something in here like my true name, etc., just not going to print that out because it doesn't have a type of string, right? All right, confusion, things they need clarified. I'd like to continue on, but with full heart, full eyes, heart full of. Sorry, let me start over. Can't fail. Just want to make sure this makes sense to everybody. I want to explain things that don't. Yes.
I forget. Is this JavaScript being saved in the
This JavaScript is being saved as app.js in my text editor onto my computer. If you want to take a look at this later, I'm going to be uploading this to my GitHub repository probably sometime tomorrow when I have the time. And I'll, as usual, announce it, send out a link to it if you're on a mailing list or Facebook or Meetup or whatever. Cool. Okay. So that's cool. We now know how to iterate through an array simply by counting up a number and then just getting the value based on that number. Pretty straightforward. Okay, it's time for our, oh, I'm sorry. Let me see if I can answer that question about that if statement. Yeah, okay. Let's learn one more thing about arrays. Arrays have a length property on it. But arrays also have a function living on top of them. That's interesting. They have a function living inside them. That's a better way of putting it. This function is called index of. Interestingly enough, index of is a function that you can not only run on arrays, but you can also run it on strings. Maybe I shouldn't have mentioned that yet. That's going to confuse things. Okay, so let's talk about what index of does. Array of strings dot index of etc. Array of strings index of etc. is 5. So it's kind of like the opposite of doing array of strings index 5, right? See? See the difference there? The big difference, though, is that this is not an array. This is not a function call. This is not a method call. This is just me getting the index of my array. Whereas this is a function which is kind of hidden its way into this array, and I just have the ability to call it, pass in a string, and get back a number. Pretty cool. What happens if I try to pass in a string that doesn't actually exist inside of array of strings? I get -1. That's weird. -1 is basically the value saying there is no index. It's not in this array. I looked through it. I went through every single value and couldn't find anything. So I'm keeping it at -1. That's where I started. That's where I left off. Yeah. So dot index of parentheses. This is a function that every array has built in. And like I mentioned, strings actually have it too. This looks very strange, but hello dot index of O is 4. Isn't that interesting? 0, 1, 2, 3, 4. There's the O. Can I also do hello index 4? Yes, I can. That's interesting. Strings are a lot like arrays, aren't they? They're not. They have a different type, but they do have that same index notation, and they have that index of function that makes them work in very similar ways. Because if you think about it, a string really is just an order of characters. 0, 1, 2, 3, 4, 5, 6, 7, 8. Just the characters keep going on. So you might as well be able to use that same index notation to get a single character outside of that thing, and to find out what the index of a specific character is on that string. Yes?
Is there such thing as strings of arrays?
Strings of arrays, no. Strings just contain characters, and that's it. But yes, arrays of strings, yes. Strings of arrays, no. Okay, so that's cool. Now, how is that useful? Well, it was asked earlier. what about checking for a whole bunch of different favorite colors, right? Like this code up here. Favorite color. What's your favorite color? If favorite color is blue, do this. If favorite color is periwinkle, do this. Else do that. Well, what if I have like 5 favorite colors? And I don't want to have to write an else and if loop. Do if this, else this, else this, else this, else this, else. I don't want to have to do that over and over, right? What if I could just what if I could just put all of my favorite colors into an array and just check to see if what they've entered in is within that array. So check it out. Let's try this. I'm going to uncomment this code. I just got rid of that little /* and I got rid of the / there. So make sure you get rid of both of them. There should be 2 things you get rid of, the // and the /*. So what's your favorite color? So instead of doing if favorite color is blue, I'm going to change this. I'm going to say if blue, periwinkle, rainbow, that's not a color. What else do I like? Pink is cool. And goldenrod. So if .index of favorite color, is greater than -1. Okay, this is a very long line. Maybe I should split it out a little bit. So I'm going to do that. I'm going to say var Jeffrey's favorite colors Okay, so I just created an array called Jeffrey's favorite colors. I want to make it too small. And so I'm just going to replace this with Jeffrey's favorite colors, index of favorite color is greater than -1. So remember we showed here that we can do index of so-and-so, and if it's not in there, then we say -1. So here's my favorite colors, and we're checking to see the index of the favorite color that's been typed in. If the index of that within this array is greater than -1, that means it must be somewhere in the array. Why in this case don't we say greater than 0? Why do we say greater than 1? Sorry, why do we say greater than -1? Because 0 is a valid location. If they say blue, that's index 0, right? So if we say Jeffrey's favorite color is that index of favorite color is 0, then that would mean that they typed in blue, right? So let's try it out. Just simplifying it, because I don't need to have an else if, else if, else if. I just need to check to see the index of this string within this array. Let's try it out. Oops, I have to restart this tab because I clicked the little box that says don't show me any more prompts. Yeah, so I'm actually also going to comment out this for loop because that's going to get annoying. So goodbye for loop. Let's open this up again. What's your fave color? Let's say rainbow. Mine too. Let's try it again. What's your fave color? Red. Lame. I'm wearing red. Yeah, but anyway, that's kind of how it works, right? Any questions about index of?
Is there ever a possibility where the number index returns a higher number than what it was indexed for?
No, I don't think that's a possibility. If if this thing only has 0, 1, 2, 3, 4 index, those little index locations, then you'll never get like index. You'll never get like 5 or more out of this.
Okay.
Yeah. Question of. But yeah, you will get -1 if it's not found at all in the array. So as long as it's greater than that, then you're good. I mean, you can also say like, and index of is less than 5 or something, if you wanted to make sure that things weren't going crazy or whatever. But
What's the array not
What?
Less than array.1.
Less than or what? Sorry.
Less than array.1.
Yeah, less than array dot. Yeah, you could do that too. Exactly. Of course, hopefully that would be, that kind of, you don't really need to check for that sort of thing, because you'll either get -1 or a valid value. Yeah, cool. So all good? Makes sense? Cool. Let's continue. So that answers the question from a lot earlier where we were talking about how to check for a lot of colors all at once. Okay, great. Let's continue on to our final data type that we have to learn, since we already learned what functions are. We're going to talk about objects. Okay. So even if you don't know what an object is, this looks pretty straightforward, right? It's a list of information that has a bunch of keys and has a bunch of values. So these things are called keys. And these things are called values. This is a key-value pair. Now here's a question. Why is this stuff indented? What's going on here? No. There's an actual reason why I'm using a square brackets here. Anyone remember what square brackets are used for? Arrays. That's right. So let's take a look. This is an object. This object is like an array in that it stores multiple pieces of data. But what's interesting about objects is that the pieces of data can have labels or keys associated with them. So if I were to get something like obj index name, that would be Jeffrey. See how inside these brackets I'm passing in a string instead of a number? That's the difference between arrays and objects. With arrays, everything has a numeric location. With objects, everything has a key. So as you can see, just like with arrays, you can store different kinds of data inside an object. Here's a string. Here's a number. Here's another string. Here's an array. And then inside this array, what is the type of data inside this array? Huh? An object. That's right. Here's another object. So this object contains an array that contains an object. Now, I only have one sibling, so I could have just said sibling and not used an array. But let's say that, sorry, I just thought about my parents. Never, okay, okay, they're done with children. Yes, so anyway, I only have one sibling, but here we go. And so but if I did have multiple ones, then I could go something like this, right? So there you go. I could, and so now I've got an array with two objects inside it. And this is how data structures work in the JavaScript world. You have objects, you've got arrays, you mash them all together, you got values of strings and numbers and things inside them, and that's kind of how it all works. And with this structure, you can lay out any type of data. Anything. This is the way that computers often communicate with one another. When you're on a website that is talking to a server and transmitting data back and forth, it's often submitting it to the server in this sort of format, and it's sending it back in that sort of format. This format is called JavaScript Object Notation, and otherwise known as JSON, J-S-O-N. So if you ever heard the term JSON, that's what they're talking about, JavaScript object notation. So this is kind of the modern way that computers communicate. I have a website that I created called Lunch. Lunch allows people to communicate back and forth and get data about, sorry, let me say that. Lunch allows people to vote on where they want to eat. We went to this crazy quinoa automat where you've got these cubby holes, and they've got people working behind the cubbies, and they insert food into the cubbies. But when the cubbies, a lot of talk about cubbies today. When the cubbies have the people putting the food into them, they darken. So you don't see the human hand writhing inside that cubby, and it makes you think like a machine has done it, although there's actually like a poorly paid worker right behind the cubby doing all the work for you. Anyway, that's where we went today. So in the background, I'm able to see data sent back and forth, and let me see here. WebSockets, and hello. I'm trying to look for data. Oh, never mind, no data. Let me think of something else. So instead of that, let me go down to the bottom of this HTML page and show you some data that has been loaded into this page. So as you can see on this page, I've got a list of a lot of restaurants that we like, that we like, quote unquote, to go to, right? But we scroll way down. This is a lot of CSS, down here at the bottom. And let's start at right where we start to see color. There we go. Here we are. Right here is where I've defined a massive JavaScript object. Truly massive. A whole lot of information inside here. And the first key is restaurants. What is restaurants? Restaurants happens to be an object. This object has some information in it. Is fetching is a Boolean, false. Did invalidate, false. Items, look, it's an array of items. Now this array is very, very big. The first in the array has an ID of 81, a name of Itza, an address of 1 California Street, a lat of 37, a long of 122, negative 122, and then some sort of weird place ID, a date that it was created at, but that's a string, a vote count, which for some reason is a string even though it could be a number, etc. But going on and on and on and on, I'm not going to read this whole thing out, obviously. But the way that this website received all this information from the backend is through a gigantic JavaScript object. So that's how computers communicate with one another. Cool. So anyway, here's a much simpler object that just contains a few different things. Any questions about how these objects work? So one thing I want to talk about is arrays and that whole type of thing. When you say type of so-and-so is an object. Well, arrays are objects. They're objects with the ability to iterate through them. They have a few extra methods sitting on them, like index of, and a few other sorts of special methods that are specific to arrays. Arrays are kind of a subset, a subclass of objects. But, you know, we could also treat this object like it's an array, right? We could say 0, my, 1, name, 2, is, etc. And then I could say obj 0, right? And that would be my. Right? So these keys can be words. They can be things that look like strings, kind of. But they can also be numbers. And so in that way, it's almost exactly like an array. It's just let's just kind of read out in a different way. In fact, if I go back to this page here and open up my console, and take a look at array of stuff, and open up this array here. Look what happens when I open up this array. I put a little arrow next to it. Look, 0 is 1, 1 is 2, 2 is 3, etc. Looks very much like an object, right? That's because it is. This array is being listed out like it's an object. It even has a special property on it called length. See? Just like we saw earlier. But it also has a whole bunch of weird prototype methods. Index of, join, keys, find index, find, fill, entries, every, copy within, concat, a whole bunch of other methods that you can use. You can learn all those on your own. Well, we'll talk about them sometime later. But yeah, there's that. So objects, they are the structure that we use to store multiple pieces of data in a single variable. Arrays are a certain kind of object that you can easily iterate through because whenever you add something onto an array or create an array, everything automatically has a number associated with it. Yeah. Another thing that I didn't talk about with both arrays and objects is the fact that you can add stuff onto them after they've been created. I just went ahead and created this object here. I also created these arrays. But I can mutate these arrays. I can modify them, manipulate them in objects. So if I said obj name is Bob, what's the difference between line 75 and line 78? Other than the name difference. Yeah, this is comparison, and this is assignment. So very much like I can assign values to variables, I can also assign values to indexes of an object. So, save this, reload, take a look at obj, and name is Bob. Even though I set up there name is Jeffrey, I changed it here. So those things can be changed. Can we do the same to arrays? Stuff index 6 is going to be obj. Yep, we can do that. Array of stuff index 6 is obj. That should put our obj at the very end of our array of stuff because our array of stuff currently has 6 things in it. So index 6 is actually the 7th place. Remember, because it starts from 0. 0, 1, 2, 3, 4, 5, 6. 6 is going to be 7. Sounds weird, but I know. It's just because it counts differently. So let's take a look at array of stuff. See? There we go. There's that object at the end. Open up the object. My name is Bob. Siblings, someone else, right? Now here's a question. Is this the easiest way for me to add something to the end of an array? This makes the assumption that I know exactly how long my array is. And I don't have to do that. I could do this. That's a little better, maybe. This is me saying, whatever the array of stuff.length is, let's create a new thing on that. Because if you think about it, the array of stuff's length starts out as 6, right? When I say array index 6, remember that counts from 0, so that's like putting something at the very end. So that's cool. That's something you can certainly do. This array of stuff.length is going to resolve into a number, which is then going to be passed into these brackets here, and it's going to allow us to assign objects to that index. But that's still a little silly. So why not just this? Ta-da! Here's another method, that is to say a function that lives on this object, or this array in this case, called push. And push just allows us to put an object at the very end of it no matter what the length is. We don't have to know the length. It'll figure that out for us. It'll just put a little thing at the very end. So if I keep both of these lines, what's going to happen?
Objects will appear twice.
The object will appear twice. It'll appear at index 6, and it'll appear at index 7. Let's check it out. Array of stuff, check it out. There it is, twice. Cool? Because these two things do the same. So you might as well use .push because you don't have to figure out what the length of the array is. There are a whole bunch of different array methods that are worth learning about. If you search up array on the Mozilla Developer Network, you'll get a list of all the cool things you can do with arrays, methods. Array is array, array of. Array instance methods. Length. There's copy within, fill, pop, push, reverse, shift, short, sort, splice, concat, includes, join, slice, toSource, toString. Cool stuff. There's a whole bunch of stuff you can do with arrays. And remember, arrays are just a special kind of object. A lot of those methods, sorry, I take that back. Maybe one or two of those methods can be used with regular objects, but many of those have to do with like the length of something. That's something worth noting. Objects don't have any built-in length. You'd think, oh, okay, well, this object contains 1, 2, 3, 4, 5, 6, 7, so that means it must have a length of 7. But no, length is something that only lives on strings. I'm sorry, on strings and arrays, both of them. They both have .length. But not on regular objects. I mean, you can add a length to this thing. You can say obj.length is 1, 2, 3, 4, 5, 6, 7. Great. But do you think that's going to stay when we add something else onto obj? No, because it's just a regular value that we set on there, right? You know, so that's not. Oops. Oh, that's not going to work. Great, length 7. But let's say obj something else is. Oops. What's obj.length? It's still 7 because it's just a value we put on there. It doesn't know anything special about the length property on objects, only on arrays. So that's something worth noting. Okay, so last leg of our class. We're done talking about objects for the most part. We're done talking about arrays. We are going to talk about functions. Now we talked about functions earlier, about calling them. We talked about them last week. You know, confirm, alert. We've seen a lot of them at this point. We've seen index of, we've seen push, we've seen alert, confirm, prompt. Those are all functions. Some functions live on objects. Oh, one more thing. Sorry, before I can continue, I have to talk specifically about living on an object and what that means. I did obj.length. How did that work? Shouldn't I have done this, obj index length? Yes, I could have. Now, I did earlier, I said obj foo. Does this mean that I can do obj.foo? Yep. So with objects, specifically, not arrays. You can't, like with an array of strings, you can't say array of strings dot 0. That's not going to work because that's an unexpected number. It thinks you're putting a decimal point at the end of your array. So you can't do that with arrays. But with objects that have keys that are just strings, essentially, you can either do obj foo like that or obj.foo. It's the same thing. So for example, this obj has the alert. Oh, I'm sorry, it doesn't. Never mind. It doesn't have a function in. But let's add that. Obj.alert equals alert. What's going on here? This is probably important to talk about before we can create our own objects. Sorry, before we can create our own functions. Talking about what's going on here. Obj is an object. But isn't alert a function? When we say that alert is being assigned to obj.alert, is that going to immediately call the alert function? Is the alert box, that dialog box, going to pop up? Nope. All we're really doing is just making a reference to alert on our object. So obj.alert is a function. Notice that it didn't run. If it ran, we would have seen something pop up there. So how do we run it? Like that, right? We run functions by putting these parentheses at the end of them. That's executing a function. Illegal invocation. Okay, I guess I can't do that. I guess for security reasons, you can't copy a built-in function and add it to an object and then try to run it from there. Probably because of weird context variable scoping stuff that I'm not going to get into. But I don't know. I guess that means that we have to create our own function, right? But oh no, one more thing before I continue. I've got that array of stuff, right? Array of stuff dot push something. That works because push is a function that lives on array of stuff. Could I also do this? So I just talked about how these two things are the same, right?
Is that an array in the string?
This is an array of stuff. This variable it contains an array. Push is a method, or that is to say, it's a function that lives on this array of stuff. And so this method is being called with something. So because this lives on this array, we can refer to it like this, or we can refer to it like this at all times. It's just two different ways of doing the same thing. So since we're referring to the push key that lives on an array of stuff, and it's a function, we can call it. And it worked. Now array of stuff contains a few somethings at the end. Something and something. We did it twice because we did it here and there. And it gave us back the length every time. That was helpful. That's cool.
Doesn't parentheses kind of synonymous with string to some degree?
Nope. Has nothing to do with strings. Has to do with functions.
They're just operators, right?
Nope, they're not operators. They are parentheses. In the case of being put after functions, they mean that the function is going to be executed. That it's going to receive input and it's going to provide output. You got a question?
Push is again a function.
Push is a function.
Also key.
Push is a function that lives on an array. So that means that array of stuff has a key of push. So we can refer to it like this or refer to it like that. So array of stuff index push is a function, so we can call it like that. So I give this funny little metaphor about what a function is like. A function is like a stick of dynamite. Just because you're handling a stick of dynamite, just because you're looking at the stick of dynamite doesn't mean it's exploding, right? But you can light the fuse and it can explode, right? So you can pass this stick of dynamite over and around and everything, unless it's one of those like old sticks of dynamite from Lost where you drop it and it explodes immediately. But don't do that. But you know, it is a thing that you can hold and you can do something to it. You can pass it around. You can assign it. You can also execute it. You can also run it by putting these parentheses at the end of it. So just keep that in mind because it's a data type just like all the other ones. Just like a string, number, Boolean, array, object, etc. A function is yet another type of data. And just because it is an array doesn't mean that every time you're referring to it, it's automatically running all the code inside it. That said, let's start to create our own functions that we can either refer to or that we can run. So this is how it looks. So this is how you create a function. You use the function keyword. The function keyword, much like if, while, and for, takes a set of parentheses, and then it takes a block of code. So again, just like up here where we did if, and then parentheses, and then block of code, or we did for, parentheses, and then block of code. Same thing down here. Function, parentheses, block of code. Yes?
Is there a name for that procedure?
Yeah, it's a keyword. I think that's the best way of putting it.
Keyword is always going to be that style.
We have a parentheses and then block of code.
No, I'm talking about code brackets and the space.
That's what I just said. Parentheses, block of code. Curly brackets denote, sorry. Curly brackets denote a one of two things, actually. Let's get this straight. Up here, when we say var obj, we got these curly brackets denoting that this is going to be an object. The object starts and ends with curly brackets. But down here, we're also using curly brackets. But this is not an object. JavaScript, unfortunately, uses the same symbol, or same set of symbols for two completely different things. It's actually kind of, it haunts me to this day. It's something that I run into day in and day out, which is, we've got an object here, and we can tell it's an object because it's got these parentheses. I'm sorry, it's got these colons and commas. Why did I say parentheses? It's got colons and commas, colon, comma, colon, comma, colon, comma. Whereas this has a bunch of JavaScript statements, often terminated by semicolons. So even though it's the same curly brackets, they're two totally different things. So let's take a look at what we got here. This should be obvious. We're saying create a variable called say hello and assign it something, right? What we're assigning it is a function. This function, when run, does console.log hello. So that's interesting because this function calls another function, right? When we run say hello, it's going to run the log function living on console. What is console? Console is an object, right? Because it's console.log. Log is a method, otherwise known as a function living on an object, that when called logs something to the console, right? So let's try it out. Say hello. Hello, and then undefined. That's interesting. Say hello, hello, and then undefined. So that's a little weird. What's this undefined? Do you notice how to the left of hello, there is no little icon there? Right here, there's this little right caret. And right here, there's this little left caret, right? But right here, there's nothing. That's because this line is asking for input. And this is the output from that line. But inside this function, we're also logging out to the console. See the difference? 1 plus 1, we just type it in here, and the output is 2. We call say hello, and it's going to log out hello, but the output of running the function is going to be undefined. And we've seen that before with alert. Hello world, and then output's undefined. So why is that? That's because this function does not return anything. This function has no output. It does something. It has a side effect. The fact that it runs this function is part of its processing. It's part of its inner workings. But it doesn't actually output anything. You can think of a function as a big worm that eats dirt and spits out other dirt, right? But it's also got like a whole bunch of hearts and weird things inside it and stuff, right? There's a whole bunch of other stuff going on inside there. And console.log is one of those things. But this function neither accepts anything, accepts any input, nor does it provide any output. So let's, even though I just talked about undefined, 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 let's talk about input first. Input is provided inside these parentheses here. Input is also provided inside these parentheses here. So let's see how that all works. Var say something nice. Actually, no, sorry, say something creepy. It's going to be console.log message plus lady. That's a cool function. So let's take a look at the difference here. This function expects to be called with a message as input. And so it uses that message, concatenates it to this string, and then it logs it out. So essentially inside here, we're declaring variables. We can name these things anything we want, but we can't assign them anything we want. That assignment happens when we actually call this function. So over here, let's save this and run it out. Say something creepy. All lives matter. All lives matter, m'lady. See? Pretty creepy. So there you go. Pretty terrible thing to say. What we're doing there is we're passing in this string, and we're getting out console log that plus something at the end. See? Sorry, I got political. But welcome to Noisebridge. Anyway, I don't believe this. That's why I'm saying it's creepy. Okay, anyway, sorry. So, gosh. So back to JavaScript. Whatever you pass into this thing, gonna get political again. Yeah, see? It's just going to add that onto it. So that's what this function does. It logs out that plus the little thing at the end. Now, that's cool. But what if we don't want this thing to have side effects? What if instead we want it to just give something back to us that we can use later on in our code? The thing about a console log is that it's logged out to the console, but we actually can't get it back. Once it's out in the console, we can't use our JavaScript to like slurp up whatever's in the console and use it. That's not what the console is for. The console is for developers like us to take a look at what's going on and sort of do a little bit of debugging and seeing like, oh, that's what's happening here. I can tell because it's just printing it out as we go. But what I want to do is take this function, or take a function like prompt, and then get back the string, and then use that string, right? So as you can see, this is output from that thing. So let's learn about output. Let's learn about returning something from a function. It looks like this. I'm going to change this to give me something creepy. And instead of console.log, I'm just going to say return. There we go. Give me something creepy. And instead of logging anything out, I'm using the return keyword plus some sort of value following after. Cool? So what does that even do? How can we use that? Well, let's start off and take a look at how this differs. Give me something creepy. I love you. So check out that little thing there. See the little left arrow there? That means that this is output. The result of me doing this line of input, this line of JavaScript, this is the output. And now that we've got that, we can store it. We can say var creepy message is give me something creepy. Wowzers. We get undefined, but we always get undefined when we create a new variable. Var creepy message. There's no output from creating a variable, but now we have that variable, and there you go. And now we can use that to do whatever. You know.
Make an array of creepy messages.
Yeah. Just make an array of them. Exactly. Just keep running them. Iterate through a certain number and push them onto an array, and then out comes a whole bunch of creepy messages, right? Something like that. So that is how you provide a function that takes input and provides output. Now, one more thing about functions is that they can also accept multiple inputs. Functions only provide one output, one return. That's something specific to JavaScript. There are some languages where you can return things called tuples, or others, or spread out your returns into different sorts of things. You can destructure your return statements from things. That works in like both, I think, Ruby and Python and some other interpreted languages. But in JavaScript, there's only one return statement. But you can have multiple inputs. So it looks like this. See this? This takes two things. So when we call make sum, we're going to pass in two things, not just one. It's going to look like this. Make sum 2, 4. See how it returned it? There you go. Of course, we can't use that unless we store it in, so like the sum is make sum 2, 4, and now we have the sum, and we can do whatever we want with it, right? But there we go, a simple adding machine. Yeah.
Function when we create, or is it necessary to give a return statement every time, or is it not a good practice?
You do not need to provide a return statement. Most functions, I like thinking of functions as pure machines that take input and provide output. But not every function has to do that. Functions can also have side effects, where they can operate upon other things that have already been defined somewhere else and change them around. This is not really the way that I like to use them, but you certainly can change things. Like, for example, looks like this. No input, no output. But it has a side effect. Side effect is that when you call this function, my name is changed. So this is important. This is actually the last little bit that I wanted to talk about. And it's about scopes. The scope of a variable. So out here on line 94, I defined my name. Here, within this function on line 97, I'm reassigning a new string to my name. But within this function, my name was not defined. But that's okay, because functions, by default, can access all variables in any parent scope. So the idea of scope is this code block right here. This block of code, it creates a new function scope. Inside here, you can create some new variables. But those variables, as long as you declare those variables inside here, they only exist as long as this function is running. Once that function is done doing its code, all those variables are freed up. They're gone. So, but this has the side effect of changing my name. So, let's just try it out. My name, screw up my name, and my name. See? So there's that. But let's try this. At the very, very beginning of the first class, I think someone asked if we really needed to use var or not. In this case, it's different. Things are different. Var, being used inside here, means that we have declared a new variable called my name. Is that going to confuse JavaScript? It might confuse you. I'd recommend maybe not doing it, but it's not going to confuse JavaScript. We have two variables now. My name within the global scope of the document, or of the JavaScript file, or in this case, the global scope of the window. But we also have this function scope, my name. So let's try screwing up my name again. My name is Jeffrey. Screw up my name. Name is still Jeffrey.
This is why so many functions use a variable I. That doesn't matter.
Well, it's worth noting that this is not a function. This is a for loop. And we declared variable I, but for loops don't create their own scope. So if I did I, we'd see it's 5. That's interesting. I is 5. Why is that? Because I exists in the global scope. I is less than or equal, in this case, it's equal to array of strings.length. Otherwise, this would have run forever, right? So I plus equals 1. Array of strings is 1, 2, 3, 4, 5. And so when it's all done, when 5 is no longer less than array of strings.length, when I is no longer less than array of strings.length, it becomes 5, and we still have access to it even after the for loop is over. So it's a good question, but in this case, it's not a function, so you can use that var I everywhere. Yeah, we even could have just done this, and then just kept this blank. In fact, we could have done, we could also have done this inside here, You got rid of that. We have also put this whole thing in an if statement, and then break out of the for loop if I is not less than greater. So like all three of those little things are. Anyway, sorry, that's me going on a tangent. But yeah, in this case, there's no special scope created for this, even though these are blocks of code. It's only inside a function that an isolated scope is created, where you can create. Sorry, not an isolated scope, but a one-way scope, where you can create variables and they can't be accessed by the outside, but you can also access outer variables and they can be changed and accessed and whatever else from the inside. So, but if you use the var keyword, then anything that you create in here is going to only live within there, and you no longer have any access to it. So even though I can run this function as many times as I want, and I'm never going to have access to gummers because it's only going to be right inside there. Cool. So it's getting pretty late. Let me introduce one final thing. We talked about console log, that you can use console.log to log stuff out. You can log it out anywhere. You can do console.log my name. So this still doesn't return anything, but you can console log it, right? So let's try again. Screw up my name, dummers. Screw up my name, dummers, right? It's console logging out dummers, right? But if you're really going to start to write really complicated code, you're going to start putting console logging like everywhere. And that gets a little annoying, especially when you have to get rid of it all by the time you ship it out to production or whatever. So what I'd recommend is learning how to use the debugger, which is built in to your developer tools. In Chrome, if you go over to the sources panel, and you go to your little file manager here and click on app.js, you will see everything that's over on the left there. Let's make this full screen so we can just see all the code we've written. Oops, that's not helpful. Is this helpful? Okay, so I just closed my little console here. Here's all the code we've written. I want to pause time. I want to go into bullet time and be able to move around freely and see what's happening around me at any point during this code. And you can do that. Check it out. I'm going to put a breakpoint on line 50. The way that you set a breakpoint is just by clicking on any one of these line numbers. What does a breakpoint do? Well, I'm going to reload the page, and we'll see what it does. We are now paused. You can tell that I'm paused because this page still seems like it's loading. We've got a little resume icon over here on our little panel over here. And this line is highlighted. What's going on here is that we are frozen on line 50. If we take a look at our console, we'll see that all that stuff that always prints out isn't being printed out. If you want to open up a little mini console underneath this stuff, you can press escape. And that'll pop up this little thing here. So check it out. What is I right now? I right now, wow, my stuff is running really slow, is 0. I thought I was 5 earlier, right? But I is currently 0 because we're within the first loop of this for loop here. So that means we can say, like, what's array of strings? Index I. Wow, that's really slow. What's going on with my computer? That's extremely slow. Well, whatever. So what I'm trying to show you guys is that you're able to pause anywhere you want, set these breakpoints, and you will be frozen. And you can check stuff out. You can log out data here. You can find out what all your variables are. You can check your call stack if you know what that is. You can check your global scope, your window scope, and see what all your values are. There's a lot of them living in the global scope there. That's not very helpful. But you can also, resume and then go to the next breakpoint. Then it's going to keep going and then go on to 50. I'm not sure why my computer is being extremely sluggish. And then, resume. Or you're going to get rid of your breakpoints entirely and just let the whole thing just continue on its way. And then it'll just print out the rest of the stuff, and then you'll be back to your regular stuff. But I don't want to get too far into it, but debugging is very helpful. It allows you to stop your code anywhere and see exactly what's going wrong, and check it all out. There's also the ability to step into a function, check to see what happens when you run that function. Step out of that function if you're done seeing the code inside the function. Step over it if you don't really care what happens inside a specific function. All these little things, step over, step into, step out, they all help you navigate throughout your code as you're debugging. So that's helpful stuff. But yeah, that said, I'm all done. Want to double check, no questions. So yeah, that's really all I wanted to talk about. We created functions, we created objects and arrays, and we pretty much learned about every data type within JavaScript. We learned about different kinds of loops. We learned about iterating through arrays. Referring to functions inside objects, adding different things into an object and pushing stuff onto the ends of arrays, a whole bunch of stuff that we can do. And really, everything that I've told you is like, 95% of the stuff that I do with JavaScript on a regular basis. This is all, like low-level programming stuff, but it's all very helpful. So it's stuff that you should understand going forward. In future classes, this knowledge is still going to come in very, very handy. Yet we are going to start using frameworks that will help us start working with code on the web. Specifically, that is to say, it'll start us help work to create web pages that are powered using JavaScript. So the next class, I'm going to introduce jQuery, which is a JavaScript framework. That is to say, it's just a big JavaScript file that someone else has already written that makes it easier for you to interact with web pages using JavaScript. So that is what we'll learn about next week. As usual, I have an assignment to give out for this week. It's about creating functions. I also, will send it out to the Noise Bridge stuff. Keep informed, join one of these things. The class materials, what I worked on in this class, will go up tomorrow if you want to take a look at it. On Thursday, I've got a lab where you can come over and learn more, try your hand at it, try the assignment out, or work on it at home, do whatever you want. but I'm here at Thursday at 7 p.m. That's it. Donate to NoiseBridge. See you guys on Thursday and then Monday. So bye. Everyone's brains exploded.